So in this video, let's solve a problem for DFT using direct method. So the question is, find the DFT for the sequence x of n equal to 1, 1, 0, 0. Okay. So from the given value of x of n, discrete time domain signal can understand. So okay. So the length of the sequence is equal to 4. Okay. And also the length of the sequence starts from x of 0. Since we don't have any arrow mark, you can understand the first value will be the x of 0. The second value will be x of 1, x of 2 and x of 3. So we all know, we will be familiar with the formula for the formula for finding the Fourier transform, which is equal to x of k is equal to summation n equal to 0 to n minus 1 is x of n e power minus j 2 pi n k by n, where okay, k is equal to 0, 1, 2 etc. up to n minus 1. Okay, so you must be familiar with this formula. Okay, so now what we are going to do is, so again here the end denotes the length of the sequence. So in our question the length of the sequence is 4. No, so we'll substitute the value of n. We can write x of k is equal to summation n equal to 0 to 3 x of n e power minus j 2 pi n k by 4, where k is equal to 0, 1, 2 and 3. Okay, so in this n is n equal to 4, it's n minus 1, which is equal to 3. So now what we do, first step that we do is, let's expand the summation. Okay, and by substituting the value of n. Okay, so if you need to expand, first let's substitute n equal to 0, which will be equal to x of 0 e power minus j 2 pi. Okay, instead of n it will be 0, k by 4 plus x of 1 into e power minus j 2 pi 1 k by 4, okay, plus x of 2 into e power minus j 2 pi again 2k, 2k by 4 plus x of 3 into e power minus j 2 pi 3k by 4. Okay, so now what we will do, we will substitute the value of x of 0. So what is x of 0? What is x of 0? The x of 0 is 1. So 1 into, so this is actually e power 0, right? E power, something we're going to multiply by 0, which becomes e power 0. Again plus x of 1 takes the value of 1. So x of 1 is 1 into e power. So minus, if we just divide it by bit, so minus j pi k by 2. Okay, plus value of x2 is 0 and x3 is also 0. So 0 into something is 0 and x3 also 0. So 0 into something is 0. Okay, so you can write x of 0, x of 3 becomes 0, then the times becomes 0. So it will be like 1 plus e power minus j pi k by 2, right? So where k is equal to 0, 1, 2 and 3. Okay, so now what we will do, this is your basic, after expanding, your x of k is given by this. Okay, this is what you should remember. Okay, now what we will do, we'll substitute we'll find the x of k by substituting the value of k. Okay, first let's substitute k is equal to 0. If you put k equal to 0, so x of 0 will be equal to 1 plus this, instead of k, this entire terms becomes 0. So it is e power 0, which is equal to 1. So it is 1 plus 1, which is equal to 2. Okay, so then let's say we have finished for k equal to 0, then we'll put k equal to 1. Okay, substitute k equal to 1. So x of 1 is equal to 1 plus e power minus j pi. Okay, instead of k, if we put 1, this will become 1. Okay, which is equal to k by 2. Okay, so it is 1 plus e power minus j pi by 2. So what is minus e power minus j pi by 2? So just nothing but 1 plus, if you just expand it, cos pi by 2 minus j sin pi by 2. So cos pi by 2 is, cos pi by 2 is 0, right? Cos pi by 2 is 0 and sin pi by 2 is 1. So this terms will become 0 and this term will become 1. So if you write this, which is equal to 1, this term is equal to 0, okay? So 1 minus j, because sin pi by 2 is 1, which is equal to 1 minus j, okay? Now let's put k equal to 2, okay? We have finished for k equal to 0, k equal to 1, okay? Now let's put k equal to 2. So x of 2 is equal to 1 plus e power minus j, okay? Instead of k, put 2, okay? So put 2 by 2 cancel, which is equal to 1 plus e power minus j pi. So it is 1 plus cos pi, minus, okay, minus j sin pi. So what is cos pi? Cos pi is minus 1 and sin pi is 0, which is equal to 1 minus 1 plus of minus 1, okay? 1 plus of minus 1, which is equal to 1 minus 1, which is equal to 0, okay? So so it is cos pi is minus 1 and sin pi is 0. So it's actually 1 plus of minus 1, which is equal to 0, okay? Now let's substitute for k equal to 3. We have finished for 0, 1 and 2, okay? Now let's substitute for k equal to 3. So k equal to 3 gives x of 3 is equal to 1 plus e power minus pi 3 by, okay, is equal to 1 plus e power minus j 3 pi by 2, which becomes 1 plus cos 3 pi by 2 minus j sin 3 pi by 2. What is cos 3 pi by 2? Okay, what is cos 3 pi by 2? So cos 3 pi by 2 is 0, okay, and sin 3 pi by 2 is minus 1. So 1 plus 0 of minus j of minus 1, which is equal to 1 plus j, okay? So we have got the answer. So for x of 0, for k equal to 0, the value is 2. For k equal to 1, the x of 0 is 1 minus j, and for k equal to 2, we have got 0, and k equal to 3, we have got a value of 1 plus j, okay? So if you write the final answer, x of k is given by, okay, for x of 0 equal to 2 comma 1 minus j comma 0 comma 1 plus j. So this is the answer. This is the answer, like by solving the sequence x of n, okay, using direct method, okay? So direct method is nothing but substituting the formula and getting the output, okay? So once again, let me revise. So what we have done here is we just substituted the formula. So first we have expanded the equation. First we have expanded, that is we have expanded the summation. So by substituting the value of n equal to 0, 1, 2 and 3. Then after substituting the value of x of 0, 1, 2 and 3 from the question given, then what you have done is you substituted, you have find out the value of x of k, you substitute the value of k. So once you have done, this will be your final answer, okay? So thanks for watching this video. Thank you.